Hello students, you are welcome to the last unit for this course, Curriculum Studies in Mathematics Education. My name is Justice Yosin Mensah, and we shall be looking at assessment in curriculum and preparing to teach senior high school mathematics. As usual, we are going to have 6 sessions, and in the first session we are looking at assessment and evaluation component in the curriculum. Let's look at the session objectives. By the end of the session, you should be able to explain 4 characteristics of a good mathematics task. In the previous unit, which was unit 5, we talked about preparing to teach JHS mathematics, and we touched on key components that will help you as a teacher to be able to teach JHS mathematics. Now, in our previous sessions, we learned about the 4 components of curriculum, and assessment was a key component. We talk about goals, methods, materials, and assessment. So we have looked at all these things, the goals, methods, and materials. We are now looking at the assessment component of the curriculum, and we are talking about the SHS mathematics curriculum. So as I said, in this session we shall learn about the assessment component of the curriculum. But you bear with me, or you attest to the fact that you have already taken a course in assessment in mathematics, and you may refer to that model for the course for details on if you have forgotten about assessment and evaluation. You may refer to that model for that. So in this session, we shall introduce you to some techniques you can use in assessing your students' learning. So, and we will focus on how to select good questions and related tasks, so that will help you to teach effectively. So as I said, you have already taken a course in assessment in mathematics education. So refer to that model if you need more information on assessment. And we are going to look at Van der Waals 2013, who identifies some characteristics of tasks based upon their cognitive demand. So we are going to look at 2 experts in the field, and the first person we are going to look at will be Van der Waals, who proposed some characteristics of tasks based on students' cognitive demands in 2013. So the demands are as follows. Worthwhile tasks should have high cognitive demands, and by this we're saying that we should have a non-routine task in nature. Non-routine means that it's not always that you'll be giving students the same set of questions, like textbook questions and all that, but they should be non-routine in nature. You should vary the tasks and make it in a problem form, so that they can, students can have or students can think about it deeply before coming out with the solution. And then, so this will encourage students to think deeply about it. The second characteristics of tasks based on students' cognitive demand is multiple entry and exit points. And by this, it says tasks that offer various ways to tackle them. So tasks should not be one way. They should have different ways of tackling them, of solving those problems or tasks. And by multiple entry points, it means the task should be or can be approached in a variety of ways and has varying degrees of challenges within. So the task shouldn't be a one-way task. It should have varied ways or variety of ways that students can tackle those tasks, and have varying degrees of challenges that will make them think deeply about it. And by multiple exit points, it was referring to the fact that there is no one way for students to present their solutions. So students can present their solutions in different ways. So in the form of group work. When you give group work, you say that this group will come and present their solution in a way, and another group will present it differently. So tasks should have multiple exit points where there is no one way for students to present their solutions. There are multiple ways of doing that, and with that you get a better insight into students' learning when you see the way they are thinking. When groups or individually they present their solutions differently, then you can see the way they are thinking and be able to excite students for them to persevere in solving them. So when the tasks are in that order, then they'll be excited when solving, and if they get it wrong, they can persevere in solving them. And then making use of examples from students' immediate environment. So you also make use of students' immediate environment, as we said earlier on. That will promote participation, and they will see the tasks to be within their domains. Tasks that address everyday activities. So there are some concepts in mathematics that address everyday activities, such as percentages, ratios, and those things. Shape and space. So all those things, you see how you give students tasks that will address everyday activities. The students get to see the utility value of mathematics and are motivated to learn it despite how challenging tasks may be. So if you give students tasks which have these characteristics, then they will see the utility value of it, that the usefulness, and then that it's either immediate usefulness or future usefulness, and then they'll be motivated to learn it despite the fact that the mathematics that you are doing may be difficult. So these points talk about the third characteristic, which says that worthwhile tasks should have relevant context. So all the things that I've mentioned that you can see under all talk about the third characteristic proposed by Van der Waal in 2013, that tasks should have relevant context. And then Reyes et al. In 2019 also proposed some characteristics of good tasks, and according to them, good tasks are often authentic in that they come from students' environment. So as we saw in the previous presentation, Reyes et al. Also says that we should always connect the task to the students' immediate environment so that they can see the utility component of it. And the good tasks are also challenging, yet within students' reach. So they are challenging, all right, but students, they are within their reach, which means when they think critically, if you create that atmosphere where they can think critically, they will be able to solve the problem or perform the task that you assign to them. So one characteristic of a good task, according to Reyes et al., that they are challenging, yet they are within the student's reach, and it should be able to stimulate students' curiosity. You give them tasks that you say, there's an answer somewhere, we must find that answer. They'll be curious, and then they should be able to stimulate their curiosity. And then encourage students to make sense of mathematical ideas. So they shouldn't see the math they are doing as just some abstract something, but also make sense of them, because you are able to link it and contextualize it within their environment. And then encourage multiple perspectives and interrelated mathematical ideas. So you have multiple perspectives. They should see the problem from multiple angles, and then there should be interrelatedness in the mathematical ideas that you present. Next, skills development in the context of problem solving, and all these things were proposed by Reyes and Long in 1945, as cited in Reyes et al. 2009. So these are some of the characteristics of good tasks as proposed by Reyes et al. In 2009. With that, we have come to the end of the first session of Unit 6, and the question I'll leave you with is explain 3 characteristics of good mathematical task.